Yes, Happy New Year. Hello. So, welcome, I guess, to the third event of this event chain that we have created. And this event will be mostly focused about data storages and how you can store the data and what are the options for, I guess, doing the stuff with data in Microsoft Azure Cloud. I will cover, I guess, most of the standard use cases. But at the same time, if you have any questions and you want to strive away somewhere differently, we can also try to explore the unknown grounds. So it's more fun, I guess, if we try to kind of be more dynamic with the content. Content itself is more or less based on one presentation from Ignite. So who has seen all presentations which happened in November in Ignite in US? So it was such event. Nobody? Okay. So who has seen some presentations from there? Like, let's say keynote. Two keynotes. I guess it had like two parallel keynotes. Okay, so some people, so cool. So hopefully you will see the slides for the first time. They are of course a bit changed and template has changed and so on, but essentially they are bluntly borrowed. So just leave the copyright. Notice, as you could say. Then other thing, before I start and jump into things, I want to ask about this, let's say, kind of offline hacks that you have. So how many of you so is there somebody who is not participating there? You don't know what I'm speaking now about. One? Yeah, it's fine. It's fine. And for the folks who are participating, so as told that you should already have kind of crafted teams, which you are where you will be kind of where you should be doing something together. And right now, the question was, how many of you have? Is there any team which has already, let's say, figured out what they want to build? One team, two teams, couple of ideas, three teams. Okay, so somebody else has a couple of ideas. Cool. So I guess it would be nice. So I just had a brief discussion about whether we could create a new channel for pitching and so on. We did Monday, but so maybe we can just create just a discussion there and say you can write down your ideas. And for the ones who need help, and also to have some things in the end actually as inspirational things from technical point of view, which you could pick up maybe for some problems that you have as you would like to solve.
Yeah.
So we'll show some sample solutions. And then that would be one. Other one is about Azure credits. So I heard that most team leaders should have received promotional codes. I know that some teams already have spent everything what they got. And another thing is that I think it kind because essentially these promo codes were just vouchers which allowed you to keep adding credit card on Azure subscription. So they also have, let's say, this 1 month limit. So if you have not, if you activated them very early, then they will come to an end at some point. No, January. So kind of that's another question. There could be some solution around that.
Yes, we have prepared a solution. So the team's activation is getting to that. So expiring just contact me and we'll take care of the extension for credit card.
Yep. Of course.
So for that, we will take over the ownership for a while. And,
yep.
But of course, with some
yes, exactly. So we will. So I will actually show a bit of that things as well, kind of fun pieces. So what will happen if you go there? So anyway, so starting with the things. So inspired. So yesterday there was a question about one use case where one team wanted to build something, and I thought about that a while, and it inspired me to create a demo for you, which I will use now to open. It's a bit strange demo, but it kind of is very related to storage. So generally, when you are hosting websites, you want to sometimes you want to save more money with that. And if you're creating very simple websites, then which don't have any backend logic, because you can create single page applications today and so on, or have very little backend logic and they don't need proper, let's say, backend systems. So then you want probably also to have this content stored on something very cheap. And the cheapest thing in cloud is just a pure storage service. And in Azure, there's an option where you can store any, let's say, static website as part of your storage, and you can expose it to internet. You can even add a custom domain on top of this website and so on, and you have your single page application running just from a blob storage, let's say, space, and serves out to internet. And it's the cheapest way how to you can serve a website from Azure. So I will show a demo of how to do that. And the question would be kind of how many of you have heard about this feature or maybe used it already? Two people, cool. Okay, so let's start. So essentially what I have, so okay, let's go here. So what I did before, just to prepare, because this is, let's say, not a session about creating a code or creating applications and so on. So what I did before, I created so I will try to use Visual Studio Code for most of my, let's say, interactions, and I installed also a couple of extensions there. So first thing what I did here, I created a folder, which is called, let me check, yeah, I think it's My Static App, which essentially contains, yeah, so it contains Vue application. And that's kind of very simple, I guess, default Vue applications that you can create with package manager. And this one I a bit customized, and what I did, I added to that a bit of agenda about things that I want to speak today. So there is just essentially a list of items that I will be presenting today, and we can discuss about them. And maybe it will not be truthful, but let's try to kind of be around that. So that's a very simple application. And one thing that we did for this thing, so I installed some plugins naturally in Visual Studio Code. So first one was Vue plugin, so that we can have nice syntax highlighting here and see some colors. And then I also installed a bunch of Azure plugins. So the ones, so essentially you can install a plugin for each of Azure, let's say, bigger service group, which is available there. And I installed the ones which I will more or less focus on today. So it will be, one is app service, naturally a bit, then storage, and Cosmos DB as well. So let's start with the storage one. So think what you need to do essentially to create this storage where you will host your website. So we'll create it now as well. So you need to create a new storage account, and when you kind of have this plugin installed, if you are authorized, it will ask you on first run to authorize to Azure. So now it's kind of on this top bar, you can see kind of the prompt where you need to enter the details. So right now it asks me for name of new storage account, so I will show, let's say, live demo. And I will check resource group which I have created for this event so that I can delete it afterwards easier. And I will pick a location as Northern Europe, and Northern Europe is located in Ireland. I have been actually, in fact, to this data center some 5-6 years ago. Then it was half empty, so I hope it's now more fuller. And the coolest thing about that, it was kind of cooling system for this data center was mostly from the air. They had huge vents on the roof, which were drawing in air, and they even said the snow is not really a problem for them because they were like huge, and like, snow could come, but Ireland probably, I mean, more people know how what's the climate in Ireland, and probably they don't get that much snow. Anyways, so this storage account is created now. And what I can do now here is in block containers. So just figure it out. Yeah, probably I can create a block container, something site. And what I can do here on this, so block containers are the most basic unit of storage in Azure, and it's essentially a place where you just put in files as unrelated entities, which was true until a bit while ago. So let's start from my first question. So with blobs and storages now in the cloud with Azure, so what has changed for me to change the statement? I cannot say that, let's say, if you use some a bit of special things when creating these blob containers, they're not really anymore just, let's say, items which are put in an object store and they are unrelated. You can also get a bit of more functionality around that, which is related to, for a hint, to analytics. So what is this function, a feature in Azure which you can leverage to kind of have two-faced nature, add two-faced nature to these things which are called in blobs, to enable you to be faster with analytics and data analysis and whatnot. So what is the feature? No? No guesses? No? Ah, so it's Azure Data Lakes. And the idea is that if you are, when you are creating a blob storage, and probably actually not from here, but from ARM template or portal or command line, then you can specify that you want this blob storage to be put also in a data lake. And what is the data lake? Can anybody tell me? So data lake essentially is, I also was actually for a long time wondering what it is. It seemed a bit strange thing. But in essence, what they did with the version 2 of Azure Data Lakes is they allowed it that, so right now, when you're putting files into Azure storage, essentially they are just unrelated entities. They're just filing there up. You can query them through APIs, get a list from them and so on, but that's kind of how you interact them. But if you look at most of analytics systems, they are built and they are treating files as part of file system. And Data Lake kind of exposes the interface to them, so you can have like tree-like structure and like file system look at your data in blob storage. And that's what essentially data lake storage allows you to do. And then you can use all these nice things which come from analytics pipelines like HD Insight or Databricks and etc. To analyze these data and maybe build some advanced analytics and data warehousing solutions where you analyze these data. Anyways, so here, I can select here as well. So I can browse static website, deploy to static website, and configure static website or disable it. So I will configure this website here. And for configuration, I have to enter what will be the entry point for this website to work. So it will be index.html. And if you are serving there just HTML files, let's say you want to create your blog, and you are using Jekyll for generating your blogs, which is an engine on Ruby, then Jekyll essentially generates just HTML files, which you can publish to anywhere. And in that case, you also would need to specify also unique path to error file or error HTML file, so that if something bad happens or 404 happens, then this error page is being shown. But as we have single page application, we actually will have to specify just the same thing. If I can back. Okay, and that's it. So what happened now is here in my storage box under live demo, there appeared this like $sign web container, which is a place where you can host your static website. So what we will do here now is we can go to, so we can click here as well, deploy to static website, and we can pick any folder on our mm, file system. So in my case, it's I will check this distribution folder for this Vue.js application, and right now it's being deployed, and I think it's already deployed. So what I will do, I will open this website. So and you can also open it. It's on livedemo.z16.v web.core.windows.net. And essentially, this site is already published now, and you can kind of see the contents of it. And if you are building, let's say, these single-page applications, which are heavy with JavaScripts or whatever, uh, then yeah, I guess this is the simplest and cheapest way of how you can store things on Azure. And you can also do some more advanced things with this one. So one is you can add CNAME records in DNS and have your custom domains here. You can also you link this together with the CDN, so that you save even more things on that and so on. So it's kind of quite cool stuff. Okay, so that was the first thing I want to show. And let's go.
Um,
Yep.
Question: how to do this without Studio?
Well, okay. So I guess so without Visual Studio Code. So I
Yes.
don't have Visual Studio actually on my computer at all. But so I guess the simplest one would be you can just write a shell script, which you can do that as well. You can just upload the thing. Another thing what you can do, there is another like applications that you can install, which is Storage Explorer, and you can use that one as well to upload stuff to this storage. Actually, let's see how it looks like from Storage Explorer. Check out open here. So what I have here is Azure Storage Explorer. Essentially, it's like application which you can install, and it allows you to browse whatever is in Azure storage. It's for free. Actually, everything that I'm showing is for free except for cloud itself. So let's refresh everything. So I just created this live demo. Also, it has the same structure, which is small, anyways. And here is this web piece. And oh, another, and it's actually also exposed as like file share. So it's like, so underlyingly behind the scenes, it also exposes it as Azure files, which means that you can, in theory, make also connection to that with SMB protocol. And if you set that it's only secure SMB protocol, then yeah, you will be required to have, I guess, some TLS certificate for authentication or something like that. And that's another option, I guess, how you can publish things. So you can map like network drive to this place because it's actually a file system. Well, it communicates itself as a file system. That would be more precise term to use. So, yeah, so here's file. I guess I'm not going to try to download it. But I download it. Or you can also upload it from here as well. But yeah, do everything from here as well. Anyways, so does it answer your question?
Yes.
Okay, cool. So I will keep in mind you. So right now I figured out, so I can treat these t-shirts. So I will give out prizes. So I guess we will make like 3 breaks. So I guess 1 t-shirt for each break. So I will try to keep in mind that everybody asks questions and give at the end of the sessions. So anyways, going back. Okay. So yeah. So I'm I guess Maciej. I work at Emergent, which is very nice and supports this event. and I'm working as a cloud solution architect there. Right now, in last months, I'm spending most of my time in a low code, no code, let's say, world. And that's why also yesterday I was just answering, let's say, where my mind was set on with answers, let's say, how to do things with the Power Apps. But overall, I have, let's say, yeah, done a lot of things with cloud. And before I worked at Virgin, I worked at Microsoft for quite a long time. My last role was in Estonia. I was working for localization team, which is now called mobile team, which essentially translates everything, let's say, does internationalization, word readiness, and localization processes for most of Microsoft products, except for cloud products. And yeah, so I have a lot of knowledge about that process as well. And today, these demos which I tried to borrow, but I will not really speak to them very heavily, are from a new Northwind app. It's now called the Tailwind Traders, which is essentially a web shop, which has some features, and it's built by Microsoft as a demo applications that you can hack and play around. It's completely open source, and you can use it for, I guess, whatever your needs are. Then in the beginning, I will a bit explain with this company a bit more, what are their unique needs, because otherwise it's a bit hard to kind of narrow things down. Then there are a bit of theory about what is storage options in cloud. We already covered some of that, but we'll go more deeper into that topic. And then first thing will be about just storing simple files. Then about storing the data into structured relationship to a database like the SQL. And after this, last but not least, is using, let's say, some document storages, document stores like MongoDB or Cosmos DB service. Uh, that will also show some nice things around that. And I have some extra topics as well if we have time. And if you have interest, we can also speak about them as well. But it also depends on what are your needs. So if you already have some ideas what you want to build, and you have some challenges which are related to data or figuring out your architecture, we can also try to discuss these things, and they can benefit to everybody here. So what is important to tell in traders? So they want to create new services and new applications quickly. Naturally, I guess everybody wants to do that nowadays. They want to limit the impact of new stuff they create on their existing stuff. So they don't want to break things with new additions and new services or features they create. They don't want to break old things, which also makes sense. Uh, they want to allow developers to go crazy and do everything they want until they cannot do it. So that's kind of to empower them to take full ownership. So it's like, you know, that let's say if you're working in some product companies, then most of them they advocate for extreme ownership. So there is a book also called like that, and there is, let's say, this one Estonian CRM company, which you probably know. I guess what it is.
Hydra? Hydra?
Hydra, yes, exactly. And their CTO is proudly telling that whenever they hire developers on first day, they can put code into production. If they break, they have to fix it, they can do it. They have all the rights. So that's so it means that whenever you create, you take full ownership of that as well. You have to fix it, and so you kind of have to be careful about these things. It's also about trust. You trust people you work with. And another one is they also want to dynamically scale storage without significant operational overhead, which is a key thing here actually, because in most of the cases, if you use services which are more managed by you, you actually need to spend more time to dynamically size these things and so on. But with the automated services from cloud, you can actually reduce operations overhead with these things and make your operations people as well happy. And also developers who kind of partially become more involved in operations as well. And they want to have full flexibility in the sense that they want to use whatever tools they want for this job. So why it's important for them to think about storage at all is because they are also in process of some migrations from legacy applications to bright new future. It's not really greenfield environment. Uh, yeah, velocity, as mentioned before. Then they also want to break features into more manageable pieces, and they want to do it with correct, I guess, intent in place. And they also want to establish robust security and strategy model about how to develop new things in the future. So if you look at clouds, this is extract of some of the platform services which are available in Azure. And today's talk is only mostly about these guys. So it's about, oh, not even all these guys. So I will not speak anything about intelligence. Yeah. Anyways, I will speak only about data piece and a bit about infrastructure services, which are storage services. I could be speaking a bit, some pieces from analytics, but not too deep. I already mentioned the data lake store, which is this thing which enables other data analytics services to consume data from data storage, from blobs, files, and disks, etc. Not disks actually, but yeah. So that's one interesting one. Other ones, yeah, I will also not really cover things which are related to backups or imports and exports to on-premises environments, but we can also speak these things if they interest you. And one other key service which I want to mention today as well is Key Vault. So that will be also covered a bit. So what do you think? As always. So first thing you have to ask to yourself is what kind of data do you have? What is structured data? What is unstructured data? What is semi-structured data in your applications? And then for all these, once you can add another dimension to make yourself even more actually, what is a great example of unstructured data? Image? Yes, good. Image is good. What else? I can also start from I just have to use it. Okay. So what is example of structured data?
HTML,
Yeah, SQL table. Yeah. Okay. What else?
XML, and everything related to that. Where structure is JSON structure, XML
Yeah.
structure.
Or is semi-structured? I'm now getting myself.
Semi-structure.
I think it's more semi-structured. Because JSON is like, it does not necessarily have strict schema, it's semi-structured.
Okay, but XML uses XSD, so.
If it has strict schema, yes. So if it has schema, then I would call it structured, but if it does not have its dynamics, then let's call it semi-structured.
Okay.
So let's kind of go with that. So yeah, and then naturally the next things we have to think about is volume, and how much of the data do we have, and how much space it will take, and then the velocity of how much do we need to read this data, how much do we need to write this data, what is the speed, how we are growing the data, and ingesting it and processing and not generating it, and then variety, in the sense, do we have all types of data, or do we have only one, or do we have a lot of unstructured data, which has tendency to change and evolve, and there was a nice term for actually unstructured data. It was that, let's say for document databases, you define your schema on read. For SQL databases, you define your schema when you're creating database, so it's like on write, you can validate it. But for document databases, in most cases, you define your schema when you're reading from these databases, because your applications which are reading, anyways, will have to be kind of anticipate some fields there, and they define actually the schema, not the applications which are outputting the data, but the ones which are consuming the data, which is kind of interesting. There's one book which I recommend to read about building distributed data systems. I think it's called something like that. Building distributed data systems. We can check later after break what's the exact name of the book. Anyways, so what do we have in Azure for storage? So we have disks, which is essentially when you are creating a virtual machine, you assign it some disks, and the disk storage is divided into ultra, premium, or standard. So standard is HDD disks, which are the slowest ones, the cheapest ones, and the oldest ones. Yes. Then premium is SSD, and ultra is high performance SSDs. Naturally, it's most expensive one. There is a lot of features which become available only with premium disk storage. But yeah, other thing is that generally people tend to like now fast disks and everything, so they prefer that one. And I guess the general assumption. Then object storage, and as I mentioned, Azure Blobs is the object store. So if you think about AWS, then it's S3. And with the data lake generation 2, you can also kind of expose the data from this object store as kind of files for analytics system. So that's kind of cool. Then you also have this file storage, which is, let's say, as abstraction on top of things. Which supports, let's say, this SMB protocol. So it's Azure Files. And another one is Azure NetApp Files. I myself don't really know much about NetApp. How many of you have used NetApp? The only thing I know about is I read a book by their CEO and founder, or ex-CEO, founder, let's say, of the company, which is called How to Castrate a Bull. Great read. Yeah. And data transport. So this is a funny one. So data transport essentially is Azure Data Box. It's a service where if you want to migrate petabytes of data cloud, you can order a box from Microsoft, which will be, let's say, they will send you a server in the box, which will be nice discussion, like something like this. And you can put your data on that, and then ship it with mail to Azure, and they will plug this box in and transfer your data on site. So pigeon mail still rocks for huge data volumes. So if you have, I don't know, a couple of hundred of petabytes lying around, then this is the thing for you. And there's also a bunch of solutions which enable hybrid connectivity, let's say, to your on-premises environments, different, and for different use cases and so on. I will not really cover them. So this is another picture which kind of goes a bit, kind of another way of same thing. So let's move. Oh, yeah. So some things about why it's better to store data on cloud versus on premises if you need some arguments at some points. So the thing is that with cloud you can always dynamically scale and add more stuff. One of the patterns actually from Tech presentation from 2014, because Azure still and a lot of cloud services they have a lot of arbitrary limitations in terms of how much stuff you can use with one account and so on. And one of the suggestions even from Microsoft, I think it still holds true, is that if you want to overcome these limitations, you can use multiple storage accounts and multiple even subscriptions and combine these things together. So when you are creating, let's say, in a sense of storage, you can create. So each storage account has numbers of how many certain artifacts you can create in them and so on. And if you expect that your solution will grow bigger, then just don't be shy and create more storage these accounts and plans that if say that such need comes and everything is great and business is rocking, then just build your, let's say, access layers in ways that you can change and adapt to this thing as you go and be dynamic with that. And it's a bit easier in my ways than, let's say, ordering the servers and then wait a couple of weeks for quote, and then a couple of weeks for until they ship even to this country. So it could be months if you are have very unique appetites. Then, in most of the cases, some companies are using cloud for their backups and disaster recovery scenarios, and they also, yeah, and so there is also a bunch of things which help with that, and you can also play around with different storage types depending on your workloads, see what works best, and learn on the go. Another cool thing is encryption. So by default, everything that you store in storage is encrypted. By Microsoft created the security keys, and then now comes the fun question. So it will be a guessing game. So storage is one of the services in Azure which support Azure Key Vault. And because it supports Azure Key Vault, which is a mechanism for securely storing certificates and secrets, you can also import your own keys. So let's say you have your own secure environment where you can generate your own keys. You upload these keys to or public key to Key Vault, which is secure there because it's also physical hardware. It's also software. Let's say security thing is actually this HSM module, which is there in cloud, so nobody can access it and tamper it from Microsoft. It's that. So then you put your encryption there, or so you can actually so you send private key there for encryption. So you send a private key and it's encrypted, and then you encrypt your storage, your private key. So then the question becomes how long virtual machines will spin up for you. Let's say if you use standard sized virtual machine, how long it will take for you to have your own virtual machine, which has not Microsoft, but your own key as security mechanics. So how long it will be? Because for Microsoft ones it takes like 3 minutes, let's say, on average. Probably they will say less. Let's say 3 5 minutes, something like that. So what will be for the keyword which is from your on-premises environment sent to cloud? Because they cannot pre-encrypt anything and so on. So what will be the ballpark estimate? It's not about exact number.
3 hours.
3 hours? Less?
10 minutes.
More?
Over half an hour.
Yes. Around. Yeah. Like a bit. It could be like 40 minutes. So it's around 40 minutes and hour and.
For which size?
Yeah, I would say standard size. Let's say S1 or something. And the cool innovation that Microsoft did with this thing to speed up the process, they decided, I guess, not to encrypt empty pieces. Yeah. So empty file of the disk is not really encrypted, but it still encrypts everything, so it's kind of still slow because it kind of uses a key from your on-premises environment. So anyways, so this kind of fun thing. So it's just the things that if you want to be like super secure, you kind of have to know the cost of that and be advised that you will not be able to scale super dynamically and as fast as you are used to in normal scenarios where you kind of don't have this full control. Another thing is if you're using any of the services in cloud, if you are thinking about this encryption and bring your own key scenarios, then you have to do like mapping and figure out, break down into the components and the architecture. Also, all the SaaS services and everything, what kind of services they use beneath them, because not all cloud services support bring your own key. And if they don't have this support, then it could be that you secure everything, but you leave something behind. And if you have this requirement, this kind of thing to be looking after. So be careful with that. Okay. Oh, the most fun part. So by default, whenever you're creating something in Azure, you get locally redundant storage, which means it's 3 replicas within one region. Technically, Microsoft, so let's say we are selecting North Europe. In theory, they are saying this is one region, So it means that there could be multiple data centers, physical locations around events in one region, uh, which kind of happens as well because the cloud grows and the one physical location could be not enough, so they could build more data centers which have some kind of connections and are not located in the same place. Your data will be stored within these, let's say, one or more data centers in that region. Then zone redundant or zone, yeah, so zone redundant storage. It is the one. So for each region, there is a paired region, and it's called zone. And so for North Europe, the paired region is Western Europe. So for West US, it's East US, and what exists. There is a special table for these kind of linked regions as well. And then there is geo redundant storage where you have 6 replicas and various sendings across the geographies within these 2 or 3 regions. And you can have another one which is read access only, so where you have, let's say, secondary node only serving for reads and primary only for writes. Well, in practice, I guess it's still a tough question. Well, we have seen in the past, in last years, I guess, some outages which have happened where one data center goes out of service. It happened more in US, I guess. They had this flooding in California or somewhere like south of US, and it took down some data centers for a while, a couple of hours. So there could be some risks, let's say, with your application availability if you don't store the data outside between multiple regions. But then again, kind of, is it reasonable and kind of how much do you want to invest into that? Because it's quite expensive. So this is, let's say, the master slide, which contains all the information about what different things are. So first is disks. Yeah, it's a thing which is attached to VMs. It's, I think, more like also, yeah. And when you are selecting premium SSDs, you also need to select special premium virtual machines. So you cannot use cheaper virtual machines, so it kind of drives all the cost of operation higher. So you kind of need to figure out what kind of things and workloads you have in cloud. Then files, which is nicer way how to access to things. You can also use files, so it provides this SMB protocol support. Also, you can use REST APIs naturally for everything, and it's essentially, let's say, for your cloud file storage network drive. Then blobs, which is a basic building block of everything. So when you are creating, let's say, virtual machines, you put them in blobs, and then another thing cool with blobs is that they have now added this cool feature, which is written here: hot, cool, and archive. And you can create policy rules that whenever you are writing the data into blobs, by default they're put, let's say, in hot level of storage. And then if nobody accesses this data for, I don't know, 1 week, you put it in cool. And then if nobody accesses the data for 1 month or something, you put it into archive tier. And you can automatically automate these things, which is very sweet and nice because naturally next tier is cheaper. And you can also create reverse rules as well. One of the challenges, of course, with archive tier is that in reality it is through archiving, so it compresses everything very tightly. And for bigger data sets, it could take also like hours or something. It's undefined at the time how long it will take to get them back up and running. But if you, from my past, that I have done, let's say, so if you're collecting a lot of telemetry or logs data or whatever, in most cases you actually don't really need that much of historical data, so you can put them in archive and then only on demand basis extract that, process it, and maybe put it back. So it's so it allows for this dynamic thing, and you can set it up without writing code, just with configurations in Azure portal or with policies which you configure in our database. which is super sweet in my mind. And there's also special types of blobs, page blobs, which are meant for media. So if you are storing videos for streaming, or you want to build your own YouTube or something, then page blob is a place where you can store things with a random write read patterns, or actually something with random write patterns. So if you want to, I guess, unify things from multiple streams into one, then maybe or have multiple internet connections coming in, the page blobs could be used for that. And yeah, append only blobs as well, which is another optimization kind of how to make things faster. Azure Tables, it's a core service thing on Azure where you can store, let's say, key value pairs on Azure. It has a lot of limitations around size of the messages and so on. One, let's say, unit of message, but it scales very well to a lot of data. It's super cheap in comparison to anything else. And if you have your keys properly set up, it also has very fast lookups. And it's also used as basic building block for a lot of services in Azure. And one interesting thing is that tables is also evolved. And in Cosmos DB, you can kind of migrate your application to Cosmos DB, and it has a bit more different, let's say, increased thresholds for some of the features, and optimized for a bit different workloads. So you can use, let's say, same API, but you can pull things also to Cosmos DB and get different benefits. And the queues, which is just a basic, let's say, I guess, thing for any cloud application or distributed system. You need to have some kind of queues or decoupling mechanics between your services or application components, and queues are also very nice for this thing. And yeah, it's also like basic building block of Azure. But because it's a very basic primitive in Azure, it means also has certain limitations, and in certain cases you could want to use a bit more, let's say, higher order of service, like Event Grid or Azure Service Bus, if it does not fulfill your needs, or you want to send bigger messages or something. Yeah, so let's say it has all the basic things built in. One interesting note about storages is that so Microsoft, you know that Microsoft kind of creates backups, and for blobs and storages, you can also have a flag that you don't have hard delete of the data there. So if somebody accidentally deletes something, you can say that it's only soft deleting data. So, and it stores data, let's say, for a week time before it actually deletes that. And in my mind, it's a very useful feature to turn on because we tend to make mistakes. We are just human, so you can try to save you a lot of nerve-wracking things, especially when you're actively developing some applications, and even when you are not, because then it's yeah, it's just you could forget some things if you have some obscure logic. That. So one note about this one, I think it's already wrong. I think Norway already launched, if I remember correctly. So this slide is from beginning of November. So there is already more data center locations. I think it's nobody else from big hyperscale cloud providers has such wide scale. A couple of notes here is that if you look at things, so what's changed, what's interesting here. China, I don't remember which one, but let's say China regions. And if I remember correctly, then yeah, let's call it China regions and maybe some other ones. So some of these are actually government clouds, so we cannot deploy anything, let's say, to US government in Texas cloud and so on. It's only meant for US government or Arizona, and I'm sure, and I'm not sure if their locations are disclosed. Other thing is that China Azure is actually separate Azure infrastructure from mainstream Azure, and they have different services and different things going on there. So you cannot really integrate with that so easily. If you're, I don't know, deciding to build business there, of course, to build a business in China, you need to have Chinese business partners, which makes things more fun. Uh, Another thing is that in Germany there used to be a German sovereign cloud, which was, and they are now kind of, well, I guess there's no official announcement, but generally they have articles written about migrate from it and move out, and they created other ones, German as well. So this all the German cloud was also separate from everything because the idea there was that it was managed by Deutsche Telekom, not by Microsoft. So if U.S. government comes to us, it's not really Microsoft data. It kind of is very similar, has a lot of services, but it's right now it's very dead in the water. There is no new services, and all the services there are quite old, and some of them are deprecated and or not deprecated yet. It's closing their end of life, so it's kind of very dynamic. And and of course it was a bit more expensive, and people I guess just wanted to use cloud, not that, not so much. And one interesting thing is also that I think Microsoft has data centers in Africa and in Arab Emirates. This is kind of very interesting because, as you know, then this could be a place of next growth where you can grow your businesses. I know a bunch of Baltic companies who are already doing that and growing big, I guess, in this region more, in Central Africa, like Bolt, for example. But yeah, so these are also kind of interesting things that you could leverage for scaling your stuff. Uh, okay, yeah, so we covered what is flops. There's like, what are the, yeah, another thing in Azure is that most of the services are kind of integrated between themselves. So here you can see, let's say, all the different, I guess some of them, but services which are out of box integrated with Azure's blob storage ecosystem, and they have default connectors. That makes it you kind of can connect between these services very much on the go. Just very simple. I don't know. Let's say if you're using portals and with just visual wizards, but if you're using other apps, then APIs are kind of very robust and easy to work together. And yeah, so we can discuss these things. Okay, so this is, let's say, my pause. But before the pause, I want to show you a bit more about stuff that we have there. So yeah, I already showed you a bit of so Azure Storage Explorer. So I would, if you want to do something with storage, I definitely recommend to download this tool. It's for free. And use it, kind of to see what are the things, and I will cover a bit what is there and some other things. Oh, yeah. So first is another thing is that you can actually also create your say local emulation of Azure environments or your own computers. So you can emulate all these services and so on without internet connectivity as well. So if you want, you can create emulation for storage drives, table services, and so on, and speed up your local development. I don't know. Sometimes people tend to work offline and so on. So that's also could be a useful feature. So first is, okay, but let's go to my cloud stuff. So I have a bunch of storage accounts. So let me go to the ones which I pre-created. Here. Okay. So here is one storage account where what I have on hot is just a file. Essentially, there could be a list of many files, which just contains this Hello World application. And I will show you kind of how you can interact with the Azure storage directly from your code a bit. So let me find it. So what I have here is I created a yeah very bad code. Don't kill me. But anyway, so what they created here is just so. What is the interesting part is this bit. So first thing what you need to do to access. So I'm using C# as a language, but you should not be scared by that. Most of the cloud. So there is APIs for most of the popular languages out there already, and if there is not, then you can also use REST APIs. And I believe they don't even have any more that much difference between using, let's say, wrapper clients or native REST API. They are quite similar. There is no big limitation between them, if I'm not mistaken. Anyways, what you need to have is some kind of connection string. I will show you how you can get one. And then when you have this connection string, you need to just create a service client. Uh, and essentially, after that, you need to get a reference to container where you will be storing something in the blob. So in blobs, they're organized that blobs have containers, and then you put files inside of these containers. Actually, this is a code which created this hello world file, and get container reference kind of also works if there is no container. If you have proper rights and proper commands, then it will just create this container for you. And when you have your container, then same way you can get reference to file, even if it is or does not exist, and then you can upload your text to the file. And that's kind of how it works. One kind of bad thing with this example is that, okay, actually it's not bad because I fixed it, but generally when you are creating these shared access tokens or whatever, you are storing them in some configuration files and so on. But if you look from security perspective, it's kind of very messy place with configs. And what kind of Microsoft advises as best practice is that you use, deployment scripts to kind of change your configurations, and that you could use also with different events to say configurations for your secrets, what you have on premises and on cloud, because unfortunately Azure Key Vault is not really exposed as emulation service for local development. So you kind of have to hack around that with some harder things, but to make it work, let's say, if you want to test things locally in your machine. But if you're using things in cloud, then idea here is that what you do is you create, when you are running this application in cloud, you create a Key Vault client, and essentially it's just, yeah, it's kind of empty thing. You don't really authenticate it against it without anything but obvious, what you can see. And what you specify here is your name of your Key Vault, and then you specify the name of the secret. It's like a Key Vault, let's say, key address. And when you have specified the secret, what you do on the cloud side of things, let me just close it. Break. So this is kind of so first is you create your Key Vault store, and when you have created, so you can have secrets, and you can change these tokens and values of these secrets. And but when people are referencing their code, they're just referencing the address of these secrets. They're not naming them. And since this Key Vault client just retrieves them on demand, and the way how it has access to these secrets is through managed identity. So idea would be that if you are creating your application, so for example, this would be the application, you go to identity tab or blade, and by default it's turned off. You turn on system assigned identity, and then you just get object ID, which is let's say principal identity for this app, and then this app gets its unique user, in which context it runs. And then what you do with this unique system assigned user, you can so it's, let me copy his name, and we see BDC. So then you can go back to this key vault service, and in key vault service access policies. So you can create access policy where you grant access to this user, which is just created for this particular application. And you can select what kind of permissions they have for keys or whatever. So essentially, you can say that they have permissions to only list and get keys and read only permissions. There is also a bit more features in Key Vault for, let's say, yeah, you can also create automated accounts and other services which are updating, creating, importing, and let's say rotating the keys. And you can also have other ones for, let's say, deleting everything. So if you want to create a red button which makes everything stop, you can create that through that as well. And you can do also some cryptographic operations in Key Vault because you can store certificates there as well. And if you store certificates, then you can leverage these certificates through this API, including your on-prem, if you have connected, because then your on-premises secure device certificates are also used through this API. And yeah, you can also manage and what of management operations your app can do, and then for certificates or special ones. So because first are like operational ones. So and when if you publish your application to cloud, it will run under this. It will be impersonated as this special user, which exists only for this application. It will have only these permissions which are specified, and that will be the mechanics how it will be able to access these secrets from Key Vault. And you will not store any secrets within your application. I read also, well, there is also a bit long article on docs called best practice, how to manage these secrets on for your on-premise local development. And let's say in cloud you use Key Vault, but if you want to hit F5 and make your application run without any connectivity to cloud, then it's a bit tricky. You have to do a bit of scripting and configurations with the JSON files. It's I think it's a bit kind of hard thing to do it once because you kind of have to invest like a day to set it up properly. But yeah, but it's kind of possible. Historically, what I have done by myself in the past, well, easy thing how you can avoid this is also if you set some kind of these compiler deployment flags. That in a production environment you use some a different class for providing secrets or these kind of connectivity actions. So you use Key Vault class which implements Key Vault and then for debugging scenarios, you use, let's say, local storage or something like that, your own custom class which you inject. But that's kind of, it feels a bit hacky, but I guess that's the way how it is. What else? Oh yeah, what I've done in the past, I have used aliases a lot. So you can specify like system level aliases and for things, let's say, which are the same, like sequels and so on, you can specify aliases and name things like web server or something, and then set up these aliases both on your own premises and production, let's say, deployment environment, so that when people are connecting, they are connecting against alias names, things, and so on. Of course, permissions should be somehow managed differently. I think this is somehow quite robust way that you have special accounts which nobody has access to, which just lives their own life. And that's kind of how you should build things to be secure. Anyways, it's time for pause. So let's make a break for 20 minutes. So it will be around 6:30. And then I will be covering a bit, speaking about SQL storage. And after that, about Cosmos DB a bit. I will not be speaking about anything about Gremlins. So if you are interested in the Gremlins talk, Sorry, I have to disconnect. It's making break. And you can come up with some different questions if you're shy to ask in front of everyone.
So, welcome back. I hope you can still grab some snacks or drinks, I guess, as well, if you want. Use your last mile. So, while I'm doing quick promo, so this is a book I mentioned earlier. It's called Designing Data Intensive Applications. It's a generic book. It's not that big. It's only like 600 pages. But it's not actually about any particular technology vendor per se. It's more about principles, how database, how you should design these data-intensive applications, and how databases are made, how they relate to physical reality, and how what we can do with them now, and which kind of style of data storage or whatnot we should use for what kind of workloads. So it kind of covers everything: how relational databases are working, how data warehouses are working, how column stores are built, and how they do their magic, and how to use graph databases versus document databases, etc., etc. So it kind of covers all of these topics. So if you're interested into deeper understanding of principles and answering questions why decisions and why systems work like they work, this is must read if you are, let's say, into that space. From technical point of view, I guess the only deep knowledge you need, well, not deep, just shallow, let's say, you should be familiar with SQL a bit, and have a curious mind to read that. It's not really that hard of a read, but it's kind of it makes you think a lot. So it's not also that easy read. So it's not like reading books about Star Wars. Anyways, so continuing. So I realized that I did not show a bit of things while waiting. So I will show you them now. And about just kind of what happens when you're creating storage from Portal, just so that we can see all the options which are available to us and so on. So let's create some new storage account. So that I can kind of briefly go over all of the options and the things which you should kind of have to think about when you're creating something in cloud. So first thing what you do when you are creating anything in Azure, you have to select your subscription. So in my case, I'm paying with my card. Next, second thing what you select is resource group. So in my case, I'm putting everything into one resource group because I want to delete everything in the evening. And then you need to select the name of storage account. It kind of somehow has to be unique because these URLs are generated with this name in it. So we have to be creative. Let's call it Baltic. And so we have a lot of guys in CES. Okay. So we could call Baltic CES. Cool. And it's available. We will put in Western Europe, so we can put in any region which we can select from here. So my preference is West Europe. You can also put in France, Switzerland, Brazil. Oh, and one very important catch: when you are calculating the costs of cloud services and storages in calculators or whatnot, kind of to assess the future or the bills, each region might have different pricing. So you have to kind of account for that. And if you already know which regions you will use, pick the ones which you will actually use. It will be closer to reality. Another thing is that with cloud and, well, I guess with a lot of services anyways in this world, if you're paying as you go, it's the worst way to do that. So you can get some nice discounts if you are buying in advance. So if you know that you will spend some money there, you can pre-buy some capacity, and I guess folks from Microsoft can support you with that. to have these agreements, and let's say whenever if you have these workloads at some level. So first thing what's here, what you can select for your storage account is whatever is standard storage or premium storage. So at account level, and it kind of changes capacity what you will get there. So I will pick standard, and here you can select the account kind, storage v2 or storage, general purpose v1 or blob storage. So general recommendation today is to use storage accounts v2. If we look at history, then actually this drop down just shows the history of how storage has evolved. So initially when Azure was launched, there was just a blob storage. Then there was storage v1, general purpose 1. And now there's storage v2. For legacy reasons, you can still create all the old ones. But Microsoft probably is investing more money on v2s than on any other of them. So if you want to kind of go with the future advances and developments, probably pick the one which is latest one. And if you look across all the let's say these data storage systems, there is right now this upgrade happening across most of the services. And it's also changed a bit pricing models and whatnot. So, but not all of them are rolled out. So they are kind of in different stages of maturity. So for storage, general purpose v2 is in general availability, but for some SQL services or so for some other services, they were still in a preview and so on. So it means they are not recommended for production use cases and so on, but they have better price. But so it's kind of your own decisions. And you can also select what kind of replication you want. So we covered that briefly. And you can also set what kind of access tier by default you have. So it will be cool or hot. Cool is more optimized. So let's say hot is meant for where you have to write a lot and read a lot of things out from that. And cool is more optimized for, I guess, essentially you write with same performance there, but you're sacrificing the reading speed and availability of data you put there. So it has a bit lower availability than hot tier and a bit, let's say it could be a bit slower for reads, data reads. So, but it will, I guess, have very similar performance on writing. So next thing you can specify here is also what will be network connectivity. What's interesting here is you can set it as public endpoint for all networks, so it will be just public, works for everything. And you can also set it as a public endpoint, which will work only with selected networks, which are, let's say, maybe you have some networking tunnels created with Microsoft through Express Route or some VPNs. So you can expose your storage only to these connected VPNs that you have. So it will be somehow semi public. So nobody, let's say so the idea would be that you can connect to your CorpNet, and the only people from your corporate internet environment, let's say, can access these storages, blobs, which are put there, and nobody else. And another one is private, which is the most restrictive one. Idea here would be that if you want to create something which only, let's say, some other cloud services can access, then you can also specify these specific cloud resources through, I guess, also their network subnet groups, so that so it will not be exposed to internet at all, and it could be accessed through only some other applications which you already run in cloud. So it will be kind of hidden from outside world, which is kind of nice in some use cases. Another thing what you select here is security things. So Like, do you require that data are always encrypted on transfer? Yes or no? So do you want to use, it would be alternative to this question if you're using REST API, would be, do you want to use HTTPS or HTTP? And yeah. Then do you want to enable large file shares with Azure files? So by default, it's disabled. And if you turn it on even later on, it's decision works only one way. So you can only turn it on. You cannot disable it later. And what it allows is to create a file shares which have up to 1 terabyte of data. So yeah, cool. And the nice thing which I mentioned earlier is blob soft delete. By default, it's disabled. You can enable and set retention for up to 1 year. I would say something like 7 days or 2 weeks probably would be fine. Most of the use cases. And then this is a place where you could select, and I will select, that you enable this service for Azure Data Lake, Gen 2. And yeah. So, and there is also some other feature which we cannot see. So let's move on. Another thing when you are creating any resource in Azure, so it works for all of them. You can add tags to resources, so it's like key value pairs, which you can kind of use then later if you have a lot of resources which you're creating in cloud. You can have these tags created automatically, or it's essentially a way of finding resources and grouping them together. So let's say if you are building working in a, let's say, somehow medium-sized company or even small company, but working on many different services and products, and you are using things from all over the places, different resource groups, and resource groups is not enough for you to group things together, or maybe you want to do some kind of special things for cost estimations or billing, I don't know, maybe your services are kind of related and kind of how you find them. So it's essentially a way how you can mark these things with special labels, and then you can set rules based on these labels as well. What can happen and what could be done with them, who can interact with them and whatnot. And you can also find them and list them and get some insights about the usage of these things and so on. So it's you can kind of get nice billing reports based on these tags as well. So if you're building some service and you are then transferring these charges to your customers, you can see which pieces of your service cost you the most of the money if you use them. Another cool thing, so now I'm in review and create step. So kind of it's all these configurations what I did. Cool thing is that you can download Azure Resource Manager template, which is essentially this JSON file, which will contain all the decisions which we made, and you can use these templates as infrastructure definition as a code, and you can store them in I don't know, version control system as well. And when you are publishing your applications, you essentially what you can do, you can just upload these templates to Azure and say create environment like this, and these ARM templates will do that. So if you're using maybe a bit advanced tools like Terraform and creating these Terraform like configurations, behind the scenes they're also generating these ARM templates and taking into account all the dependencies of services and so on. So that's kind of how it works. Yeah, so you can download it or add it to your own library. I guess I will not do that now. So I will just create it. And while it's creating, yeah, so deployment has happened, and you can still download also that ARM template later on. So one of the things for teams which overuse their accounts maybe, and they want to migrate them somewhere and so on. So the easiest thing what you can do, you can just download ARM templates of all of your infrastructure components and just upload them to Azure portal and redeploy them in other subscription. So that was the simplest thing what you can do. if you kind of, yeah, if you created everything by hand. So you can kind of ease redeployment in future. Okay, so we created it. So what is another interesting thing? Yeah. So let's go through that. So yeah, by default you get also some statistics about egress and ingress. So what is the data in and data out, latencies, and how much requests you get. Kind of important thing about to keep in mind about clouds. I think it applies to almost all big cloud providers. So data which is incoming to your application is for free, but data which is going out actually is limited in a way. So you have most of the services have like default free levels of data which is going out, but when you exceed these levels, and they are not that much high, but let's say if you hit I don't know, let's say 10,000 of users daily on your application or website, you probably will exceed them. Then you have to pay additional money for traffic which is leaving their data centers, and you even have to pay this money if you are doing data replication. So if you are transferring data between different data regions, you are also paying these egress fees on that data as well. There is one cloud provider with exception to that, but I will not name it. So about between these cloud providers, data centers, about traffic and so on. There is ways to optimize these costs through using express route, which is you can create like a tunnel connection between Microsoft data center and your network through express route, and I think it's also possible to do it here in Latvia as well. And you can also use others ways how to kind of buy, but express route is the one which kind of covers the most of the needs for these scenarios, let's say for your internal communications. Okay, so a bit moving forward. So yeah, first all services in the cloud have activity logs where you can see who did what with these subscriptions and whatnot. Here you also can control access to these resources there. You can grant roles or deny assignments for people or whatnot. You can use identity providers, or you can also do it at the system level for system identities, managed identity services. Like I mentioned earlier about this key vault storage. So you can see tags, or you can add tags as well. This one is probably, yeah, so I will not go. Interesting note about Azure storage is that whenever there is something happening to this data, you can also subscribe to events. Like if there is new blob created, file updated, file deleted, etc., etc. So it fires event which you can handle and manage, and you can use these events then in your application later on for some logic and workflows. And in practice, what happens behind the scenes, it sends event to Azure service, which is called Event Grid. And Event Grid is publish subscribe style service, where you send in a quick message that something has happened, and some information about where it happened, and then you can consume it. It's consumed by most of Microsoft applications already, but you can also use it in your own applications. And the easiest ways how to consume these events, if we look at modern application design, is one is through logic apps, which is quite powerful tool how you can manage, let's say, integrations between different systems and build the logic there. And the other one is, let's say, if you're more closer to the metal person, as they can say, you can also create your Azure functions, which is essentially serverless computing, where you, or well, serverless is bad name, I hate it, but essentially you can write small piece of function or of code which will be triggered on some of these events, and so we can, let's try to see. So, and it will be able to process it and do something further down the chain. So you can kind of build your application logics based on these events and create event-driven applications, which is kind of very nice. Another thing what they did now in preview, so there's also a bunch of services which are in preview stage. They also created, let's say, within browser, like so this Storage Explorer application, which I showed you on my computer, installed one. So they also have like similar view to that created in a browser window as well. So the fun part now is settings, and access keys is the one which is most interesting one. So for this, so these are the keys which are used to access the resources from code, and essentially you always get two keys. Maybe somebody can tell me a reason why you have two keys, and why keys are better than passwords. That's a bonus thing.
One is only for looking, and one is like admin key, and one is
I think these ones are like super admin. Exactly. It's more about changing in this particular case. These are like admin keys. You can do everything with these keys. But the idea is that you should always kind of think that you need to have multiple keys alive at some point. They could overlap even. And if you want to do key rotation, if you take, let's say, disable first key, and your application is not updated to some other key, your application will break and it will have downtime. So you need to put some other key in place, or maybe just refresh the second key, still keep first key alive, and then redeploy application with new key. Both of keys works, and then disable the first key again. So these kind of scenarios. So it's yeah, so it's essentially for making operations easier. And this also is the reason why keys are way better than passwords. Passwords are the worst thing in the world, because with passwords you will always have downtime when you are changing them, and normally you probably should change them, because yeah, that's how you get hacked and get to meet folks of GDPR police. What else? Oh yeah, and so first thing is you get a key, and the second thing is connection string. But connection string is essentially, it has a bit more metadata information, and essentially is the same key which is on top included into that. So if you are crafting your connection strings with custom logic or something, you don't really need to have that whole connection string saved as well. But it's kind of just a shorthand to make things easier. And you can rotate keys. Well, one is, oh, another thing. Everything that you see here in Portal, it's also a trap. So Portal is user interface, and the approach with what Microsoft has taken with most of Azure services, it's kind of best practice, but not all teams fully follow that, as I have learned. But let's say the wishful process is that teams at first develop API, so it will be like REST API or something. Then they create a command line interface for this API, and only later on they create a Portal interface for these things. So there could be some of the features which are not exposed here in Portal, and you cannot see them, but in reality you can make them work through things behind the scenes. So, and historically there have been a lot of things which have not been exposed visually here as well, but this is just kind of nature of things moving fast. Wait. So, okay, next one. So whatever you can do from visual interface here, you can do from code, and you can automate it. Well, that would be, let's say, the bottom line. So here you can see how your application is working, and in which places your data is living, and what is the status of your data in all the locations. If you would be replicating this data from Europe to US or something. One thing to keep in mind is that if you are doing these replications, of course they come at cost, and it decreases, let's say, the data which will happen in, let's say, if you copy data from Europe to US, there will be some latency between. There was a nice chart somewhere. I saw it, I think, in one presentation about the cables, what Microsoft and other global companies have created around the globe. So they have put huge cables in the ocean, across the globe where they connect all their data centers. Essentially, they have their own internet backbone going on across globally. And one of the cool things they can do is that they also have deals with the internet providers that they share IP addresses. So if you are going to Microsoft service, then they try as fast as possible to get on Microsoft internet, not the global internet, because it will be faster, safer, and they have more control. There is some nice things which are developed for that in Estonia, but I will not speak about publicly that. Then another cool thing, because as I mentioned earlier, everything is available as API. You can define, so you can access all the services through REST API. So if you are doing that, there is support for CORS. You can specify which commands and methods from REST APIs are allowed from which places, and so you can manage, let's say, this cross-origin scripting attacks. So you can limit or increase security of your applications through that, so that you allow only some certain messages coming from external sources and whatnot. So it's additional security layer you can apply on your applications, or maybe let's say you should apply. So basic configurations we already covered. Encryption options we covered. So if we want to encrypt our storage account, then we can select something from Key Vault, or we can enter key URI. I have no idea how that works exactly. So, but kind of with Key Vault, we already kind of touched it a bit. And then going back to your question about different kind of keys, for different purposes, you can create these shared access signatures, which are kind of unique keys for single purpose. So where you can specify different kind of settings for these keys. So they're called SAS keys, shared access signatures. So you select kind of what services you allow to access, what resource types you can interact, what operations you can do, what is the time span, how it will, from when and until when it will be working, maybe what are allowed the IP addresses, IP address ranges, which can interact with that one, and so on. So, and you also sign with which of these previously mentioned keys you are signing them. So idea would be that if you are disabling or changing these keys, you are also canceling all shared access signatures which are not created from it. So it makes management easier and improves security of your applications hugely, I would say. So, and you can also limit protocols to HTTP, TPS only, which I suggest everybody to do. So does anybody, so actually, that's another kind of nice question. And one thing is, I forgot to give away. Okay, I will be revised. So, okay. So should we see any pages on internet which use HTTP today? No. Why? Nobody uses SSL. Don't make mistake. I have made it, but never. Don't say in 2020 that you use SSL. TLS.
I think people from outside who just look
Yeah.
at your homepage,
Yeah.
they see browser not secure, and they think it's dangerous.
Well, it is. Especially if you have some form with postmet. But I would say there is another reason for it. The reason is that you can create certificates for creating TLS connections for free. There is no more this extortion ring going on with these certification authorities. Well, there is still, but there's not much point in that. And there is this site called Let's Encrypt, .org, which you can check out. And if you create automated scripts, it's kind of meant to be consumed in automated manner. You can generate and sign your applications with this site for free. So essentially, you get these secure sites for free. And you can also integrate into Azure. So if you are using your custom domains, you can set up your site with your own certificate from Let's Encrypt and kind of automate the process of renewing the certificate, because this site gives you a certificate for 3 months and you have to renew it automatically each 3 months. Idea is that it's purposely done because it needs to be, it kind of enforces this security hygiene of key rotation and everything. So I would say it's a key reason. It's also because it's for free now. Well, or almost for free. It's not, you don't have to pay 400 euros or something to get your site secure, which is outrageous. So next one, firewalls and virtual networks. Yeah, which is kind of another fun place for security. So you can select from like kind of define firewall rules who can access your these storage resources from which places. Yeah, I will not go into too much. Yeah, yeah. I think for that base, so in that, yeah, I think it includes these rules as well. Yeah, it should. Yeah, it definitely covers them. Yeah, for that static content site, you mean? Yeah, yeah, of course. So it has it already. Because another thing is that actually all the services which are in Azure kind of have in a middle load balancer, the ones which are managed services by Microsoft. So you have you can kind of protect your sites as well against some DDoS attacks a bit as well. But it kind of, because default behavior is unless you buy additional services, is just it kind of takes longer to respond to these who are like spamming it with requests. Yeah, question. Okay. So another one is if you have some VPN or express route connections, you can also kind of connect your site to that and force that all the connections between these places happen through that. So what is advanced security? Bum, 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 bum. I don't remember actually what was under this tag. Okay, well, it's loading. Another kind of cool feature is logs, which I will not open yet. But with logs, you can specify that you have created something in your Azure environment and you want to lock it down so that nobody else or even yourself can change it without these particular settings, without escalating and removing this lock. So there is a couple of reasons for doing that. First is that you can kind of protect your own from your, let's say if you created things which work and you apply the good old sysadmin thinking way, if it works, don't touch it, then you can kind of protect yourself from making mistakes and breaking things. Another thing is that you can protect others from making mistakes if they don't know what they're doing. And the other important thing is if you have some incidents or some bad things happening, you get audit logs of who removed the log and who changed it. Of course, you will also see all the activities, but maybe if things are locked and you specify that as a key, it will be easier for you just to find who was the bad guy who did something. It's more like it makes investigations easier in these auditing scenarios. Okay. So advanced security. Okay. Well, I guess not today. So properties, generally what it has, it lists all the REST endpoints which you can use when you are calling these services. So it kind of contains all the different internet addresses under which these services are exposed. to public. So yeah, so logs. So you can log also resource group. You can log subscriptions. You can make this some settings read only and add notes when you did it and why you did it and so on. So export template is something that I already shown. Then because we added data lake, okay, I don't have access. Cool. So something I guess expired in my connectivity. Okay. So then you can also kind of just create file shares. You can create tables, queues. Oh my God. Yeah, I guess something in my connectivity. So all the basic services which are available in storage. Then interesting thing from monitoring is insights. So essentially where you get system logs, let's say, of what's happening in your application. So you can see transactions by IP names and so on, and let's say availability, capacity, and kind of what's happening with your application. Then you can set up also some alerts if based on these insights or logs or metrics that you set. If something is passing through thresholds, you should should get some notification and take a look at these things. What else? Yes, there is another thing is for some active. I guess for most of the Azure services, you also get Azure Advisor, which kind of tries to look at your usage patterns and advise you how you can optimize your spendings by downsizing, maybe upsizing some kind of services and so on. But I don't really have clue about validity of these suggestions. What's interesting, of course, it's another example is that you need to have machine learning in whatever you're building today. So it's machine learning service which learns from what people do with their subscriptions. So what else? Yeah. So something. So I have some red connectivity things not configured. So cool. Okay. So that was a bit about all the kind of settings that you can set on storage accounts. And another cool thing here is you can also have kind of sample applications and quick starts for all the popular programming languages and environments. Well, not all of them, but some of them, like definitely Node.js, Python, Java applications, .NET applications. With .NET, you kind of have to be careful if you want to use .NET Core or .NET Framework. There is a bit differences. Azure CLI, which is a new or modern way of interacting with Azure from command line. So there is old Azure PowerShell control plane, let's say commandlet, but the future is in Azure CLI because it's cross-platform and the cloud is cross-platform and nobody should care about operating systems that much. So what else? Yeah, that's it. So, okay, I guess my internet is just getting flakier. So yeah, relational databases. So let's talk about them. So I guess easiest thing is to start with okay, I will start the slides just to make. Oh, okay. Let me just find it. No. Okay, cool. Wait, the wrong one. Yep. So what do we have here? So what are our options for that? Well, I would say, I guess everything. So Microsoft historically has developed its own SQL database. There is quite many different options how to deploy SQL database on Azure as well. But if you are not a big fan of SQL and you like PostgreSQL because it is the most awesome database management system in the world for relational database, you can use that one. You can use MySQL, you can use MariaDB as well. I guess also other ones like SAP HANA, if you are into SAP world, and column stores more than Oracle as well. And generally, in most of the cases, there is even support for bring your own license, which is the most cost-efficient way to use it. So if you have your on-prem SQL licenses, you can bring them and drive the cost down for these services in cloud. Otherwise, it's you kind of pay twice for it because it's included in subscription fee for service. You also are paying this licensing fee as well if you're using Azure SQL. So, and with PostgreSQL, one interesting thing is that Microsoft last year or 2 years ago acquired a company which was building, let's say, high-scale Postgre setup, and that their service is also available as part of Azure now. I could ask, kind of provide you a secret, or not as a secret. What would be the database which was used behind the Skype back in the day when Skype was created? Which was the database? Actually, it's listed here. So, which was used for Skype for storing accounts and everything? Of course, it was Postgres. The reason is that Skype was created in which year? No. It was like 2003 something, maybe earlier. Yeah, I think so. It was recently 15 years old. So yeah, something like around the early 2000s or middle of 2000s, and yeah, and kind of Postgres in their mind had the most of the power, and they did not have to pay anything for licenses. They were poor because they were startups, so they took Postgres and took it to very huge scale, and a lot of their learnings also were then applied into Azure. So actually, Azure has benefited a lot from learnings from Skype engineering. But yeah, anyways, so you get that one, or you can use SQL. What is in SQL interesting thing? What was recently announced or shipped? I think it was last year. Was managed instances, which allows you to kind of have managed SQL instances in cloud, and it's kind of the easiest way to have lift and shift deployments from on-premises to cloud for SQL Server workloads. There are limitations to all of these, and you have to be very aware of them and research them before you are doing anything like that. What else? And then there is also some other services which are related to that. So let's play a game a bit. So do you know Azure Data Factory? Okay, cool. One person knows. And what is Azure Data Factory? Two people know. Okay, what is Azure Data Factory? Oh, I need to throw. Sorry, I have to use it. I have to throw it. You will catch it? Or okay, there's water, so I will pass it through. So I will. Yeah.
Yes. It's a microphone.
Yeah, you're speaking to it.
So okay, as I learned, recently I learned that Azure Data Factory is kind of really cool tool to get data from various sources, and like there's source and there's sink, so it can take data and either map or transform or do various actions to data and save it into another place. And also, as something that I recently learned, it does not play well with Cosmos DB Azure Table APIs or data interface.
Okay, interesting.
Yeah, it was a nice learning experience, or rather not.
Okay. So we probably
Did I answer?
yeah. So one kind of very cool important feature about Data Factory is that it allows, if you have used SQL integration services, you can run kind of these packages or jobs you created there. You can just upload them to Azure Data Factory and run them there. So you can kind of lift and shift your SQL integration services. jobs from on-premises to cloud. You don't have to worry about it anymore. Um, what else? Yeah, so analysis services is something for your data warehousing, and yeah, like machine learning is just yeah tool. I guess we will have more demos on that next week. So I will not go into that. Yeah, okay, let's go next. Oh my God, I have transitions. So for SQL, you have you can create, let's say, just an instances of that. Where you just create it's like old way of doing SQL in Azure, where you just create a database with some size. You can maybe expand the size of this database until a certain limit, not too big, like terabyte or half terabyte, if I remember correctly. And then you can also bundle these instances together into elastic pool if you have higher workloads, but also still have some limits also on size of database. And then you get managed instance, which is the new offering from last year, which has more customization options for you. So you kind of can almost have feeling like you are managing your SQL server, but not really. Some things are kind of taken away from you at a cost, of course. So, okay. What else? Yeah, and if you are using that, then generally there is no changes in queries that you have written, almost, except for if you had queries which were accessing file system, you kind of have to change the calls which you had to local file system for some other files and configurations to calls to the blob storage or some other places. So that's kind of the big one. Tools, yeah, you can use whatever tool you want. So I will show a demo with the SQL Management Studio, how you can access the data and see what's there, and how you can also connect it to it. Oh, and one other thing, when you're creating SQL instances, by default, it only works with the IP address whitelisting. So if you have so right now, I will probably fail to connect on my first try because my IP address which I have in this place will be unique and new, and you cannot access these databases without specifying concrete IP addresses. But unless you create other like VPNs and whatnot. Yeah. So what else? Fine. Yeah, that was all the slides I want to show. So first thing I need to increase a bit. All right, okay. And let's go to Management Studio. Okay. So what I did to prepare, I created my own SQL database. And okay, cool. So I will go through that process with you as well, so that we can see how things work. So first thing what you can see here on top is when you're creating some Azure services from portal is let's say you see SQL database, you see Azure database for Postgres. I will not use that one, but I want to show you this thing what I mentioned earlier. So here you can select between single server, which is kind of basic thing how you I guess deploy Postgres service, and you can also get this hyperscale Citius, which is this company which I mentioned earlier, which will create high performance and ultra kind of multi-tenant like a server group or for Postgres, and you can do a lot of interesting things with that. So if you have bigger database than 100 gigabytes and so on, so the data guys at in Estonia, the ones who were managing Postgres stuff for Skype, historically they were kind of very happy about this acquisition. They like wanted to go and have drinks with the guys and so on, because yeah, they were kind of all the industry is very, I would say, connected, and I would definitely recommend to go network with people and kind of hang out. Anyways, let's create new SQL database, and because I wanted to show some things. So yada. And let's configure the sizes, which is a fun piece, which is an interesting one. So historically, when SQL launched, it had this concept of data transactional units or something like that, which is a special way how it calculates its how much the service will cost to you, and how much DTUs you are using, and how big your database will be, and it's like combination of CPU usage and whatnot, and some indicators of performance, and how much do you need to use, and then it kind of gives you estimate how much this service will cost to you historically. So there was basics tier for I guess something very primitives, and standard ones which are meant for like general performance, and then premium which are meant for very intensive applications, which are most expensive ones. And then recently they changed their cost model to virtual cores, which is I guess similar to what it used to have on premises. And one thing is where you can select this provisioned application for on how many virtual cores you want, and what will be the data size that you will have, and so on. And it will essentially just allocate this database for you. But you can also pick serverless database option, which sounds super funny to me, but okay. But idea here is that you pay only for what you use, and it's like passive service of database. So if you don't, if you are creating some experiments, I guess, where you don't know what will be the load and so on, and you expect that load probably will not be that much, and you will frequently turn it off. So you can set up the rules where the serverless SQL database will be kind of disabled and go to sleep, and then wake up at the cost of being slower when it wakes up, when calls are executed, and so on. So this is kind of cool features that you can select. Also, you can see the latencies on top. So for these both options right now, latencies are expected to be 2 to 10 milliseconds. And what else? Oh yeah, and you can also select like size, how big is this serverless thing scaled up to, and but it will scale based on demand. What else is interesting? Oh yeah, and you can increase these databases to half a terabyte, and after that it will well, that's the end of the story. Unless you do some multi-tenancy and provisioning across different services, that's how big you can go. What else? Yeah, with serverless, there was some issues for people who are doing some replications across regions and whatnot. It could be that it never turns off, and you don't save any money, and it costs even more than default service. So you have to be very careful, let's say, in configuring it in correct manner, because there's a lot of settings which you can tick in a portal, which will make your serverless application to be fully persistent and always working. So be careful with that. So if you want to save money. What else? Yes, and then there is some higher speed options as well. So like hyperscale tier, and also, yeah, you can which are, let's say, faster, lower latency, more powerful CPUs and whatnot. And yeah, and on these ones you can also get a bit more storage, up to 1 terabyte. So, but they are naturally more expensive. So let's say replica secondary ones on hyperscale, vCores, I don't know, so like 2. So yeah, it will be like 3,000, no, 2,500 thousand euros per month estimation. So it could be a bit more. It could be, well, it will be around that. And so these are kinds of options. So the database which I created the database which is on this serverless level already pre-created. So let me go to that database, and I need to change its configuration. So as you can see right now, it's paused. So cool. And one thing that I need to do with this database is I need to allow myself, I guess, to connect to that database. So let me just find the correct settings and quickly can review other things that we see here. Okay, set server firewall. Cool. And add client IP. So I can add my current IP address. So I have my office IP address there, and I can add my current one, so I can make a connection. If I remove this address, then this connection would not work. So when you're creating address SQL Server service, you are specifying like admin user account. So it's built-in user principal, but you can also set it up to be used by Azure Active Directory. Anyways, so I'm selecting connecting here, and here I have some demo database with some demo data. So it's a regular SQL Management Studio that I'm using. And my internet is failing me. Oh, I guess it's because I'm streaming video as well from my computer, so it's kind of a combination of factors. And because the database was paused, so it's now waking up. So while it's doing that, some other interesting settings here, which are unique. So one is you can run some queries here as well inside of Portal. So if I log in with my admin user, if I remember password, I can write my own queries and see tables, and yeah. So it means that if I go to Studio, okay, so Studio also has woken up. So then the database is now woken up, and we can connect and query it. But yeah, it has this startup costs because it's serverless. So yeah, and here we have just a, let's say, some basic database. No, but some tables, so we can select something, make it run, and then it works quite fast. Anyways, what you can do, another thing here, which is quite cool, is you can connect your Azure database out of box to Microsoft Power Platform, which is this Microsoft solution for, let's say, analytics and work automation for business users, I would say. Low, no-code environment, and you can expose your data into Power BI for analysis, and nice charts and visualizations and dashboards and reporting, and to Power Apps for some applications, which are, let's say, simple applications which people could create with drag and drop. You can expose your data from Azure there, and the flow for some process automation tasks. So if you need, you can automate some processes with the data that you have here. So which is also quite cool thing. And dual licensing models, it could be that at some points even more interesting than creating your own logic apps. But okay. What else? Yeah, you can select the regions where you want to replicate things. Oh, I probably don't want to do that. What else? Yeah, so here you also get these connection strings. So this one, I guess, yeah. And there's examples for different languages, even Go language. You can also synchronize it, I guess, with some other database, but I actually have no idea how this feature works, so I will not be speaking about that. And the interesting bit is that you can add Azure Search. So who knows what Azure Search is? It's managed Elasticsearch service. And what is the biggest difference between SQL and Azure Search is, no, between Elasticsearch and Azure Search is that Azure Search can also, you can specify that it uses language rules, rule set which is the same as used, let's say, in other Microsoft products, for example, in Office. So, and one of the things which it has on top of there, so if we speak about Latvian language specifically, is that Elasticsearch for Latvian language grammar understanding uses a library which was written by rector, like the head of University of Ventspils for his PhD thesis, and in '95, something like that. And in Microsoft case, it uses it also, but this library which is written there, it's open source. You can check it out on GitHub. It has like logic, which is more about removing some letters from ends and beginnings to find the stems of the words and so on, and categorize and figure out declinations based on that. So it's very kind of static, hard-coded approach. And in Azure Search, you can set it up to also have synonym libraries there. So it will search also for synonyms of the words, which is kind of powerful thing, but it comes at a cost of speed. So, but you can select actually which algorithm you want to use. So it's your own thing. So it's kind of cool thing if you want to have, let's say, good quality text search. You can also use Azure Search service, which is this Elasticsearch service on top of it. Yeah, you can also specify collations if somebody is into that things. And what else? Oh yeah, and you can. What's another interesting? Oh, from security pieces, I guess the interesting one is the dynamic data masking. So you can set up some rules for masking, and you can kind of create functions which do data masking, and that based on people access rights and roles and whatnot, some columns they will not be able to see. So this feature could be very useful. Let's say if we look from GDPR or something like that, the people privacy perspective, we can mask some columns, let's say, which contain private information with some random generated numbers or some kind of heuristics which make it impossible to identify any particular individual when you are looking at the data for analytics, but it still gives you some kind of insight, and you can figure out what you can do with this application. Or you can group together, let's say, people, instead of just looking at their age, you can group them already in the age groups which are relevant for you. Let's say teenagers or young adults and adults and whatnot. I forgot all the age groups from Sims. Anyways, uh, what else? And then the cool thing is transparent data encryption, which is this feature in SQL which allows you to encrypt what is stored. So it's encryption at rest. And this is kind of funny thing, but when we're speaking about SQL services, so when we mentioned earlier that all the storage stuff is encrypted by default, with the, let's say, these managed data services, I would say that you should not assume that it's encrypted 2 times. It probably is not. There is nothing said from Microsoft that they encrypt SQL if the data is not encrypted with transparent data encryption. So if you want your data to be encrypted, you have to use this feature. And here are some, I guess, useful things for data administrators, how they can try to figure out what should be changed in database to improve performance of queries. So you can change some settings for your database which you are running in cloud, and do a bit of performance tuning if you see that it's needed. So which is quite sweet. But as I am not really that much data administrator person, I'm not knowledgeable enough to comment whatever it's really useful. So okay. So what else? So we showed that. Oh yeah. So we connected also finally here. Shows the warm up, and what else? Yeah, I think that would be it. What I want to show about SQL. Any questions? Oh, let me. Whole database. I would say you should encrypt everything always. It's a general rule. So I mean, even Google encrypts everything, even their traffic between things for their services, like for 10 years already. So when you're building cloud services, you should encrypt everything. But you're kind of mixing two things. So if you look at this, another thing I would say is that for GDPR things, you should use data masking, and the data masking you can use only for things where it's needed, and encryption has nothing to do with GDPR in my mind, in my very simple mind, because encryption should be always. Yeah. Yeah, you cannot. So it will not be encrypted twice. I will say it's only once. But masking is not really encryption. It's more like function which runs on kind of you. When you are extracting the data out, you will not see. You will see only, let's say, stars or something like that, or whatever is the function you have selected. So you will, or some ID which is non-correlatable or something, or you have grouped results in some manners which are makes it kind of maybe more useful for analytics, but not you are unable to extract things which are too personal. Okay, so let's go to the next one. So about key vault, I think I already covered the topic, so I will skip it from demo perspective, but I will give you a warning. So whenever you're creating some kind of applications, never put your secrets and keys in version control. Please don't do that. There are nice tools which like could be part of your continuous integration toolchain, which can even prevent you from making commits to, let's say, remote repository. If you have some keys detected in your code, I know that it's deployed in some places as well. So your secrets will be visible, because whenever you commit something in version control, it is there forever, because you can go back in past and see history and everything. So whenever you do that, you kind of have to change these keys. Another thing is that some people are also using public GitHub repos because they're doing open source, and then they also mistakenly put some of their secrets also there. So please don't do that. And it will move to other places, and people, your colleagues, will find these keys. They will use them in other places and so on. It's a kind of really bad practice to do that. There is nice also static analyzers and scanners which you can use to kind of prevent this from happening. But and try to more use, let's say, yeah, something like Key Vault or other key stores on any cloud providers. All of the good cloud providers have them. If they don't, I don't know what to say about them. But generally, all of the cloud providers have their own HSM modules where you can store your secrets in very safe manner and limit exposure of security risks. What's a cool feature about Azure is that in Azure, actually, at the end of the day, all of the identity is the answer to all of the management things, and everything is built on top of Azure Active Directory, in a sense that your identity and how you interact with applications, how you build applications and whatnot, is managed through that. And you can leverage it also when you are building your line of business applications. The business users are also using their work identity and having single sign-on enabled for your applications and so on. And you can define access roles and rights through that, and it kind of makes this very centralized and controlled thing. But that's a bit longer discussion. Another kind of cool thing, if you look at general Azure things, is that it has a lot of certifications. I think it has the most certifications from all the cloud providers, which are related to security and standards. And a lot of these certifications give you some kind of blanket agreement that if you are doing things in a certain manner, then it's very easier for you to certify your solutions for broader level certifications. Let's say in case of PCI, if you are creating payment There was a trend back in the day, 3 years ago, I think, when everybody was creating their own payment processing system. I mean, there is still like a lot of payment processing systems created in Latvia, but regardless. So it was very easy to get your, well, let's say easier to get your certification done if you were doing stuff on Azure, because for some levels you could just install firewall or something and it was enough. But so you could benefit from that as well. Of course, another thing is, yeah, it kind of also makes it easier kind of when you are working with your customers to say that you could also qualify for these types of things. In bigger sense, it's also possible to, with bigger organizations and associations, if there is a need, globally, you could also do some independent audits and get some auditing done on Azure things as well, on processes. If there is need, and you can agree with Microsoft that Microsoft deems it valuable enough. Anyways, another thing, yeah. So I will be speaking a bit about document storage. So what I have created beforehand, let me show it, is Cosmos DB instance. So let me find it. Yeah, Cosmos DB. So all the Cosmos DB resources I have created, I will pick one, this one. So what is Cosmos DB? Cosmos DB is document storage. Well, actually not. It used to be, so there used to be a thing called the document DB, which Microsoft created. Amazon also now has document DB service, which is super confusing. But anyways, and it's a document storage. Essentially, you can think of it as a database where you store JSON files. That was what was Microsoft Document DB. And it's very optimized for working with JSON and so on. And then it evolved into Cosmos DB in a sense that they added the interface for MongoDB so that you can interact with Document DB through MongoDB clients, native clients, without any modifications. And other thing, it also added some other interesting hyperscale, like say global features, where you can scale this database very easily across the globe. So this will be your database if you need to scale your application across all the locations on the planet or all the Azure data centers, I don't know. And that's, let's say, hard requirement, and you want to make it easy and fast and don't think about it too much. It also has support for, let's say, this API, like evolution of table, storage table API, which we kind of, which was this key value store displayed earlier. It has some benefits over that and some downsides. And the cool thing, it also has support for Gremlin DB, which is a graph database. So if you are building your own social network or people graph or some kind of graph related things, then you can leverage that one as well. So that's kind of cool. And the coolest thing about Cosmos DB is that it's really global and it works across the kind of, it's easy to scale it across different locations. Of course, it's in terms of costs, it's a bit pricey, and you kind of have to evaluate that thoroughly. Whatever it is the right solution for you. So what is interesting here, yeah, it also has Data Explorer where you can see, let me see, what do we have here? So it has collections, and inside of collections, oh, I have like tons of documents here. Cool. I guess this is some kind of locations. Okay. Oh no. Okay, I remember now. What was the dataset which I used here? So the dataset here I used is it's partial list of movies which are available on Netflix. So yeah, so it's kind of, I uploaded here. And what else? So let's see. And one thing which I also, yeah, so another thing what you can do here is you can enable some of MongoDB features here, like MongoDB wire protocol and that you require that each request is also somehow encrypted more, and so on, which is kind of cool. So idea is that this service is evolving, it's following closely on what MongoDB is doing and trying to add all the features of MongoDB as well here from Microsoft side. You can fairly easily select where you want to replicate the data to, of course, at the cost and things. You can also change consistency, rules that you want to imply on your data stored here, which is very kind of important for document storage. So you can set that you want to have strong consistency, and then it also has a visualization about how data writes and reads are propagating across the different regions. So you can kind of see how it kind of looks in real life and what will be the issues, because I guess words are sometimes not enough, and they decided that having a picture of notes would help more. I guess same rules about firewalls and endpoints. What else would be interesting one? Yeah, that's it. So the cool piece. So one thing is you can also connect to Cosmos DB from your Azure Storage Explorer, like I have done here. But the interesting thing is that you can connect it also from MongoDB Compass, which is main client that you, let's say I went to mongodb.com, just download it without any plugins. I copy pasted the connection string for database, and here I am in the same database. And actually, in fact, I also uploaded all these data from this client up to up to cloud, let's say, from this MongoDB Compass client, which is kind of the cool piece. And if you kind of are used to developing the things in MongoDB, then this could be also useful thing. And if you if you want to leverage this service and you see the value into that, of course, if you speak about Azure and cloud services, just kind of important thing. So I was mostly focusing my talk on services which are kind of pre-built for you and are offered by Microsoft. But in reality, you can run whatever you want there. So if you have your own obscure database systems or whatnot, or maybe not that obscure, you can run it on virtual machines. But the cost is that you have to manage all the operations and logistics of that more. So it's your responsibility to update them, patch them, and so on. With these services, you don't have to care about these hygiene things so much. You have to care only about key rotation. Everybody has to care about key rotation. But outside of that, you should be fairly free to do whatever you want. And just to let's try to find what Azure has to offer for Mongo, if you want just to use MongoDB. So there is thing on Azure called Marketplace, and you can see there is you can get MongoDB community version on CentOS Linux operating system, or you can also buy MongoDB Atlas on Azure. So who knows what MongoDB Atlas is? Okay, so who knows what MongoDB.com, I guess, is? So it's a company called MongoDB, which develops MongoDB, and they have their own, same as Elasticsearch company Elastic. They have their own managed service where they provide to everybody their, I guess, product as a cloud service. So it's like SaaS for developers kind of thing. PaaS, that means probably. So SaaS offering of their database, and it's called MongoDB Atlas. And with MongoDB Atlas, the kind of interesting bit is that it actually runs on all of the clouds. So it supports Azure, AWS, probably Google Compute as well. And you can create your applications that it's even replicated across all of the clouds through MongoDB Atlas. So if you have a need and you see benefit because of some geography or other reasons, you can use MongoDB Atlas from their side, or you can also acquire it through Azure side of things. Of course, if we go from Azure side of things, then yearly cost of running it's only 21,000 euros. So yeah, so that's kind of what you can buy. And it's kind of integrated into your overall billing, so you don't have to create new procurement, I guess, for MongoDB. You can use it on your Microsoft billing, so it could be also benefiting the companies, as we can see sometimes. What else? So that would be one thing. What else I want? Yeah. So this is again different way of showing the same thing, I guess. So this is a picture of how different databases are stored, I guess, in no, but what you can do in different databases on the cloud, and what's there. Oh, one interesting thing here is HD Insight. So do you know what HD Insight is? So does anybody remember a small thing which was trendy, like super trendy 10 years ago? Hadoop. So HD Insight is Microsoft managed Hadoop service. And it's developed, I guess, in Serbia, more or less. But kind of cool thing is that it's kind of tailored for Azure, and it has evolved together with Azure, and kind of a lot of things have come out of that. And Databricks is another solution for big data analytics and artificial intelligence solutions. So if you are into these areas, I guess we will maybe see some demos next week on these ones. Maybe not on HD Insight, but maybe on Databricks, but I'm not sure. Let's see. So what I mentioned about Cosmos. So essentially it supports many different kind of runtimes for running and processing the data. So it's more like a kind of umbrella thing from one perspective, but at the same time it supports, it kind of gives same scaling promise across all of these services. So it supports key value storage mechanics, so you can use it for storing some table API data, or etcd, which is for Kubernetes key value store. Then you can use it also as column family if you are interested into, let's say, running some workflows on Cassandra. And now my trivia knowledge is starting to fail. So which company developed Cassandra? Yes, Facebook? And what was... Oh, yes, true, probably. It's because... And Kafka was developed by LinkedIn. Yes? Okay, anyways. Then, so DocumentDB is this core API of SQL. Then it also has support for Spark, which is actually managed Spark services Databricks, if I'm not mistaken. And then, yeah, MongoDB, Gremlin for graphs, so on. So what else? Yes, and you can use it for everything. So, and the cool thing is that it has this support in preview for wire protocol for MongoDB. So you can use whatever MongoDB default client is created in this world. You can use it with Cosmos DB, sorry. There is calculator for costs. Okay, so last thing. So you can kind of see very similar presentation and more presentations if you go to this link, which is at the end, aka.ms/apps20. There's also a bunch of sample applications. So there is this sample application which I did not really use that much, which was about this Tailwind traders. But because kind of demo was a bit silly. But yeah, so sample solution of what you get with Tailwind Traders, it's fully open source, so you can reuse it. It kind of contains a lot of interesting components that you can develop your application, where some pieces are written in JavaScript, Node.js, some pieces are written in, I guess, React, and something in .NET Core, and some pieces also in Java. So you can kind of see kind of this mishmash of Kubernetes hell, and also some legacy applications which are written maybe in some other platforms as well, and then kind of how it's expanded across all of the space. So you can download the source code, play around with the code, and maybe see something interesting for you. There is also like scripts that you can use for checking out things. You can for most of the things. So let's pick on this one. You can also have very nice button called deploy to Azure. So you can just click one button, and what it will do, it will take a special site where it will kind of link to the repo of GitHub, public one, and we'll set some settings and how you can deploy this application on your Azure subscription, if you're interested into that, to see how it works there. But you can also just download the source code and kind of see what is inside of it. And there's some scenarios that are covered by this sample application. So it's kind of quite interesting place for learning on your own pace and going deeper into some topics. One interesting thing which I promised in the beginning, let me just find it. Okay. So about ideas, about what you can do. So some teams of you already have ideas what you want to build. For the ones, even actually for all of them, there's a very nice site on Microsoft, which is called, so you can find it on Solutions. And there is Solution Architectures, which is kind of curated by Microsoft. But what they do here is they try to put together some sample applications which are built on Azure that you can reuse as architecture patterns. And there is descriptions of how they are built, recipes for deploying them on your Azure tenants, subscriptions, and like visualizations of how things are arranged. So you can see kind of what's inside of them, and it's a place where you can maybe find some inspiration for things you want to build. So for example, there is customer onboarding process automation solution on serverless. So what you can see it in this case, it integrates between where I have put it. So it integrates between Dynamics 365, I guess, which is meant as CRM, and then when customer goes to some website, there is some API this website is calling, and then customer face is sent through cognitive services face API to be recognized, or customer sentiment maybe is recognized, that data is saved into CRM, and then parallelly it's maybe processed, and something is maybe some email is sent to him through MailChimp, some campaign, whatnot, and that data is also collected, and at the end of the day aggregated into CRM. So you can kind of see details about these sample solutions, and you can kind of find inspirations there if you're interested. What else? Okay, so one general thing, for example, just going back to code. So we have the code here, which creates something in cloud services. So maybe what is bad with this code? Like super terrible. Never do it. So first thing I would say is that whenever you are doing a remote call to any other service or anything, you should try to build mechanics for retrying and exponentially increasing the timeouts. how you need to try at least certain amount of times if error codes are matching some pattern. Let's say service is unavailable or something like that, because you need to assume that cloud services tend to fail and they tend to be restarted or messed up. There is another product which is kind of word from house testing, chaos testing, which is also called Gremlin, which you can use to purposefully destroy your infrastructure or make your services fail, introduce network failouts, failovers, and etc. So you can test how your applications work in a case when things don't work as expected. And if you use these tools, then, for example, this application will totally fail. So so that's why you need to kind of adhere to these distributed system designing patterns. That you try to gracefully fail and try to retry things if it makes sense in a past, and also decouple things so that you have like a queue of jobs and you can pick them up and process independently, because you need to assume that any of interconnected systems will fail. So it could be that key vault service in theory could fail. It could be that some other service could in theory fail. Even if they never fail, they could, and the possibility is quite real. Of course, with storage services, it's at highest levels of availability. The best thing what you can get is 16 nines availability. So that's actually, do you know what these nines mean? So when the people are speaking, let's say I have like 4 nines, I have 6 nines, I have 12 nines. Yes, 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 yes. So yeah. So what is that? So, and it's, yeah, it's kind of percentage of the year, how much it's available. Yes, exactly. Yeah. And so, and like 16 nines is, I guess it leaves like just a couple of seconds, I guess, for failure. So, but still, it's an option. There is no service in the world which has 100% availability. Even clocks are failing that one. So, yeah. So we should be ready for things to be failing. And another thing with cloud, general cloud things, is that we should expect also that we should not make very long running remote calls, because if they are such long running, then probably it will also make headache and problems for you. So you should not create anything where you expect like process to be starting and then finishing, and this process takes like even, I don't know, more like 30 minutes, and you expect your application to resume and continue after that. You can do that, but you have to use specially built constraints to work around that and make it work. But by default, you should not build these applications like that. Of course, there are scenarios where it's totally viable, but then you have to build it in a very special way. For example, with stateful functions on Azure, which is another kind of cool thing. But for that topic, I think Valdis has done a very nice presentation. He will probably repeat it at some point as well. So that's a bit different one. So what else? So I think I went, yeah. So through most of the things, what I want to share. Oh, one other thing which I did not share, which is very big takeaway anyways. So if you want to make your app faster, just cache more. So, and one of the things that you can use in Azure for caching is managed Redis service. So use like Azure Cache is kind of Redis. So if you want to make your applications work faster, use this Redis cache. So you can kind of make things faster with that. And another thing, very useful service on Azure to use is also API Manager. So if you are designing your APIs or something like that, then I'd definitely recommend to use it. So because it kind of deals with a lot of basic problems that everybody has when you're creating your own APIs. like throttling, authentication, security, etc., etc. So, and also some, let's say, boundaries of security rules what you want to create. So definitely, I recommend to check it out if you're designing APIs. That would be also interesting thing to use. So I guess that would be it from me, unless some questions. Yeah.
Question regarding the Redis cache.
Yes.
Like if you, for example, store data in a Cosmos database, do you recommend to use like the Redis cache or?
Well, I guess it really depends on your scale. I would say at that point, it's so. Let's say I see the reason for caching would be if you hit enough traffic, and so let's say in Cosmos case, so the best way actually to cache things is actually on your machine where you're running things. So if you're running application service, I would recommend actually for you to cache things inside of your application service, somewhere there, like create a separate service which just does caching with some invalidations and so on. And keep it closer to your system as well. So with Cosmos, I don't know. I would say it really depends on use case. I cannot really give like generally probably not really, but then again, it could be useful at certain scale. So another problem with that will be also like this geolocation thing, because then you also it makes your infrastructure very complex in a way. Because with Cosmos you can select all these different regions where you replicate data. You pay tons of money for that, and then if you add caches, you also need to make caches smart that they route properly and so on. So you kind of have to take care of those that routing thing as well properly. But whenever you are using caches, please add telemetry for cache misses, so you can see how much of the calls you are making and when caches are hit and missed, and you collect that data so that you explicitly know if your cache is actually adding any value or not. Because if you will see that you, or maybe you need to change your logic of application or something, and just try to be more, I guess, aggressive with telemetry on these things. And I think always from telemetry as two-sided thing. One is from, let's say, product perspective, where you look at more like business level metrics or user behaviors in a flow of application, and other ones are more technical ones, but are very important ones, which are more mentioned about how we allocate our funds, I guess, for infrastructure and so on these services. Is they useful or not? And we should measure and experiment and see kind of how things work in real life, because we can make assumptions, but it could be that our cache is totally pointless. Because real users use your apps differently than we thought they will use. Yeah. Okay. So I hope it was fun and it was not too boring. So I guess we can stop video.